Assalamu alaikum. How are you girls? I hope all of you are fine. We're going to discuss today the first lesson in statics, which is the resultant of two forces acting at a point. A force, its definition, it is the action of a body on another body, as you can see. The force is a vector quantity. It is determined by magnitude direction. The new one is a point of action. It has a line of action. Meaning of the line of action, the direction the body under the action of the force is moving. We have units to measure forces. Any force is measured using Newton or dyne, as you studied before in physics. To convert from Newton to dyne, we multiply by 10 to the power 5. Or from dyne to Newton, we divide by 10 to the power 5 or multiply by 10 to the power -5. There are new units, kilogram weight and gram weight. To convert from kilogram weight to gram weight, we multiply by 10 to the power 3. You have to know that 1 kilogram weight equals 9.8 Newton and 1 gram weight equals 980 Newton. When can we say that a body is in a state of equilibrium? If you put any body on a table, it won't move, so it is in a state of equilibrium. Why is it in a state of equilibrium? Because it is under the action of two forces. Its weight acting vertically downwards and the reaction of the table on the body, and it acts vertically upwards. They have the same line of action, different directions, same magnitude. We discussed in class the resultant of two forces using the parallelogram as you see. If we have a parallelogram, or before having the parallelogram, we have a body here at point A. It is under the action of two forces, F1 and F2. Previously, we know that AB vector plus BC vectors equal AC vector. So the resultant of the two forces, F1 and F2, will be the diagonal of the parallelogram AC. Someone will tell me, where is F2 in triangle ABC? We know that equivalent vectors have same magnitude and same direction. So we can translate F2 to BC and F1 to DC. And they are equivalent because this is a parallelogram. BC and AD are parallel and they have the same magnitude. If the angle between the two forces is theta and the angle between the resultant and the first force is alpha, we can find the resultant using geometrical instruments. How? You are wondering how. So if F1, say, its measure or its magnitude is 50 Newton, F2 is 40 Newton, we can draw them using a drawing scale. Let each 1 centimeter be equal 10 Newton. F1 will be drawn as 5 centimeters, F2 as 4 centimeters. Let the angle between them be 60 degrees, say, which is called theta. We can call it theta, alpha, whatever. This is not a problem. Alpha is the angle between R and F1. Now we are going to draw F1 and F2, 5 centimeters, 4 centimeters. The angle between them is 60. We join A, B, C, D to complete our parallelogram. Draw AC, which is a diagonal acting at the same body at point A. Find the length using your ruler of AC. Say it will be 6 centimeters. In this case, we can say that the resultant of the two forces, F1 and F2, equals 60 Newton. Because each 1 centimeter, as we said before, equals 10 Newton. This is geometrically. You can find it geometrically. He will ask you this question in the exam. If you have two forces meeting at a point represented by magnitude and direction by two adjacent sides of a parallelogram, then you complete the sentence or you choose one of the choices given to you, the resultant will be the diagonal represented in magnitude and direction by the diagonal coming from the same point they are acting upon. Okay, this is geometrically. Now, if we want to find the resultant algebraically, we have two rules. This rule will be proven later using the cosine law. That rule will be proved later using the second lesson in statics, which is the resolution of a force into two forces. You have to know the aim of our lesson, which is we replace the two forces by just one force. This one force is called the resultant of the two forces. We have, as you see, four special cases. If the two forces are acting at the same direction, the angle between them equals 0. In this case, the resultant will be in its best case. It will be in its best case. We call it R maximum. In this case, the resultant of the two forces will be equal to F1 plus F2. Someone of you will tell me, can we use the above rule to find the resultant in this case? Yes, just put instead of theta, 0 degree. Cosine 0 equals 1. So this will be a perfect square under the square root, bracket F1 plus F2, all to the power 2. The root will cancel the power 2, and we will have that the resultant equals F1 plus F2. And we already discussed these cases in class. The second case, if the two forces are acting in opposite directions on the same line, in other words, the angle between them equals 180. If you substitute also in the rule, you will find that R will be F1 minus F2. Now, we are putting the absolute value signs here because any value coming out or from under the root, it must be positive. We must be sure it will be positive. One of you will pick F1 as 50 degrees, 50 newtons, or F2, 40 newtons. So the answer will be 10 newtons. In this case, the resultant will be equal to 10 newtons. Now, what if one of you chose F1 to be 40 newtons and F2 to be 50 newtons? The answer will be negative 10. There is no magnitude having negative sign. This is why we put the absolute value signs. Now, if the angle between them equals 90, in this case, cosine theta will be equal to 0. Cosine 90 will be equal to 0. And the resultant will be equal root F1 squared plus F2 squared. The final case, he can ask us in the exam as a complete question, if the two forces are equal in magnitude, what will happen? We discussed this in class. The resultant will bisect the angle between them because they are equal. They are equal in magnitude, so the resultant will divide the angle between them. In this case, alpha will be equal to theta over 2, where alpha is the angle between the resultant and the first force, theta is the angle between the two forces. If we have theta equals, say, 120, in this case, alpha, the angle between the resultant and the first force, 120 divided by 2 equals 60. 60 and 60. Okay. In these sheets, there will be some examples, solved examples for you. As you can see, you can read it by yourself. And I am going to pick some problems from the school book. There is no school book this year. You will find it on the site of the Ministry of Education. Let's see what we have. I am going to solve a couple of problems here. You can try yourself in the rest, and I will send you the answers on the WhatsApp. Let's see. Problem number 11. We have two forces of magnitude 5 Newton, 10 Newton, act on a particle, and the measure of the angle between them 120 degrees. He's asking us find the magnitude of the resultant and the measure of the angle made by the resultant with the first force. He didn't tell me to pick one of them theta and the other alpha. I put whatever I want, which of them is theta or alpha. Let's see the answer together. Remember, number 11 in the school book. F1 equals 5 Newton. F2 equals 10 Newton. The angle between them, theta or alpha, say the angle between them is called alpha, as we said in class. Its measure is 120 degrees. He is asking about the magnitude of the resultant. Let's write the rule. F1 squared, 5 to the power 2, plus F2 squared, 10 to the power 2, plus 2 times 5 times 10 times cosine 120. The result, let's use our calculator to find the magnitude of this resultant. The answer to root 30 Newton. If you want it in decimals, equals 10.935 Newton. Approximately 11 Newton. This is the magnitude of the result. Let's find the direction. The rule says tan, the angle between them, say theta, equals F2 sine alpha, 10 sine 120 over F1, 5 plus 10, which is F2 cosine 120. The denominator will give me 0. And we will have a value in the numerator. We know that tan 90 equals sine 90 over cosine 90. 1 over 0. It is undefined. Because of the denominators equal 0, theta must be equal to 90 degrees. Now we can say that the resultant, we write the resultant forgive my handwriting, is of magnitude 11 Newton, and it makes an angle of measure 90 degrees with F1. Now we fully solved this problem. Let's return to the school books problem and see the second problem. Let's solve number 13. In number 13, two forces of magnitude 15 kilogram weight, 8 kilogram weight act on a particle if the resultants equal 13 kilogram weight. Find the angle between the two forces. We have to notice that the first rule has four elements, F1, F2, or alpha, the angle between the two forces. If you have three elements of the four, we use the first law. Similarly, the second law, it has also four elements. Theta, the angle between the first force and the resultant. Alpha, the angle between the two forces. F1 and F2. So he is asking about what? He is asking about the angle between the two forces in number 13. We have the two forces, 15 kilogram weight, 8 kilogram weight. We have the resultant, and he's asking the angle about the angle between the two forces. So we are going to use the first rule because we have three elements of it so that we can find alpha, the angle between the two forces. Let's use this given first. To solve this problem, number 13. Number 13, the given we have F1 equals, I forgot, let's see again, F1 15 and 8 F2. 15 kilogram weight, F2 equals 8 kilogram weight. We have the resultant equals 13 kilogram weight. I will write the rule as follows. F1 squared plus F2 squared plus 2 F1 F2 cosine alpha equals r squared. Let's substitute in this rule. 15 squared plus 8 squared plus 2 times 15 times 8. We don't know alpha. We need to find it. R equals 13 squared. 169, 225 plus 64 plus 2 times 15 equals 30. 30 times 8 equals 240. This is not, it's 2 times 15. Let's check it using the calculator. 240, yes. 225 plus 64, we will add them. After adding, we will take them to the right hand side with a negative sign. This is 240, not 2400. Cosine alpha will be equal to 169 minus 289, forgive my handwriting, over 240. The answers equal negative half after using the calculator. Shift cosine negative half, alpha will be equal to 120 degrees. And this is the angle between the two forces. Let's solve another one, another problem from the school book. You can ask any question on the WhatsApp group if you have anything in Al-Muasir or the school book to ask about. Let's see number 15. We have two forces of magnitude 4 and F. The measure of the angle between them is 135. If the direction of their resultant is inclined by an angle of measure 45 on F. To solve this problem smoothly, we can make F, which is the second force, written as the second force, we can make it the first force if we want to. In all cases, we will have the same answer, whatever we put 4 or F as the first force. But it's easier to make F the first force, and 45 in this case will be theta, the angle between the resultant and the first force. and it's much or more simple to use it as a second force. Okay, let's see. Again, the data we have 4 and F are the forces. The measure of the angle between them is 135. Mister, we can use it as the second force as he wrote it because we have alpha, which is 135. In this case, theta, the angle between the first force and the resultant, will be equal to 90. Let's see. Again, the two forces, 4 and F. Number 15. For the second force, F, the angle between them, 135. This angle between the resultant and F equals 45. So theta will be equal to 90. This is the data we have. Let's revise the problem again. F1 equals 4. F2 equals F. Alpha 135. Now we can say that theta equals 90 degrees. I say we can use the second rule, which is tan theta, where theta is the angle between the resultant and the first force, equal F2 sine alpha, which is equal to 135 over F1 plus F2, which is equal to F cosine 135. We know that theta equals 90. So tan 90 equals 1 over 0, as we said before. In other words, we can say that 4 plus F cosine 135, the denominator will be equal to 0. So F equals -4 over cosine 135. Now we can use the calculator to find the value of F. It will be equal to 4 root 2 will be equal to 4 root 2. Okay. Again, forgive me, let's write it again. F equals -4 over cosine 135, which will be equal 4 root 2. Don't forget to write the unit of measuring the force, which is Newton. Thank you so much for bearing me. Inshallah, next time will be better. Thank you so much.